So the last problem was based on the combined loading. So we have to imagine at first, or we have to assume at first a thickness. So that's why we are using the thickness calculation based on the simple internal pressure. We are considering there is no combined loading, only the internal pressure. So from that we found a thickness, that is the 2 mm. Now this is a problem. This problem is nothing but trial and error type. And so our first assumptions for the thickness of the vessel under combined loading is 2 mm. Now in the following equations we will use T equal to 2. So if we apply the equation for the combined loading, so first is the Ft. So we got the value is 99.165. Now what is Fa1? Fa1 formula, there is nothing but the P di plus T divided by the 40. That is nothing but the axial stress. So axial stress is P equal to here 0.33 into di means 1200. Now we assume this thickness T. Okay, 4 into 2. So it comes around 49.5825 Newton per millimeter square. Since this is in tensile in nature, then what is Fa2? Fa2 is the stress due to its dead weight. So the formula is pi t di plus t, and it is given that the weight is 32,000. Okay, the weight was given C200, 3200 kg. If I multiplied by the G, if we consider G as 10, so it will be 32,000. Is it clear? So divided by pi into 2m into again 1200 plus 2, and it comes out as negative because it is in compressive in nature. It is 4.237. You can check the value, it may be wrong. Okay, some differences may be there. So you please check using your calculator. So negative y, this is compressive because of the dead weight. Now now due to the offset or outside piping, now stress due to offset or outside piping, so that is the Fs, and the value is 2t divided by pi t di into di plus t. You tell me the value. Value बताओ. What is the value? Why this much time is needed? Hello? Hello?
Yes, sir.
वैल्यू क्या है इनका?
0.11
Sir, 0.1103.
तो 0.1103. So this is in tensile. So if we get the resultant stress in axial direction, so it will be Fa equal to Fa1 plus Fa2. So that is 49.5825 plus minus of 4.237. So it is in tensile 3455 Newton per millimeter square. Then what should be the resultant stress due to this combined loading? So Fr, you find the value. Fr equal to, this is the formula, Ft into Fa square, this one. So put the value and tell me what is the value of the Fr. So what is the value of Fr? Newton per millimeter square. बोलो क्या होगा? Find out this value.
Sir, 85.98.
Yes, 85.98. Thank you. So it comes out as 85.9836. So this is the value of the resultant stress due to the combined loading. Okay. Now you see here this value Fr. Now you see this value, okay, is less than the tensile stress of the material, allowable tensile stress of the material. So what is the value? Allowable value, allowable stress, allowable tensile stress of the material. What it was given? It is given as, you see the problem, it is given as
130.
very good. This is 130 Newton per millimeter square. So this is the allowable tensile stress of the material, and this Fr is the stress or resultant stress due to the combined loading. So this is less than Ft. So our checking, okay, for the satisfactory design pass. So our next task is to what should be the thickness, because that 2 mm thickness was our based on the only hoop stress. So now thickness which can withstand resultant stress is E into di. Okay, so you will see, put the value 0.33, di value is 1200, then 2 into FR value is 85.9836. Joint efficiency taken as 0.85, 85%. And if you check, then the thickness becomes 7152 millimeter. So this is the required thickness to withstand the resultant stress. Now, since this is a ferrite, the corrosion allowances must be added. So thickness required taking corrosion allowances, it will be 2.72 plus 2 equal to 4.72 for the prince. यही प्रॉब्लम चल रहा है कई दिनों से. एनीवे क्या करेंगे. Okay, so so what should be the corrosion, what should be the thickness taking care of the corrosion allowances? बताओ. Hello. So what is the thickness? What is the thickness after taking corrosion allowances?
4.72 mm.
4.7.
Okay, so this is thickness is 4.72 millimeter. But you see, although this is the correct thickness, but we cannot report this because this is not the standard thickness of any metallic plate. So we have to choose the next higher value of the standard thickness of that material. As for example, it is going to be 5 mm. So 5 mm thickness or thickness of 5 mm slab, metallic slab is available in the market, but not 4.72 or 5.53. So next higher standard value you have to consider. So you see, if it was not a combined loading problem, so in that case 2 mm thickness plus 2 mm corrosion allowances equal to 4 mm thickness was enough. But since it is a combined loading problem, so we have to find the resultant stress, and after calculating that 5 mm should be your more safe design thickness. Okay, so this is the process. Now, one thing I want to say, if you find in any problem, okay, in this problem, FR, that is the value was the, what was the value? 85.9. It was the value, Newton plus millimeter square, was less than the allowable stress. Okay, that is the 130. In this case, this is the simple problem. But if you found in any problem that it becomes greater, resultant stress becomes greater than the allowable stress. If it was the condition, then you have to go for the next iterations. While in that case, you have to take the thickness 3 mm, suppose, and again you have to perform the same calculations, and you have to continue until this becomes true, means the resultant stress is less than the allowable stress. So in this problem, after doing a single iteration, the answer is found, but it may not be in the other problem. So second, third iteration, same problem, same, very easy, you have to perform. Next is that you keep on writing. Now, let us see different expression for the stress due to the dead loads in a pressure vessel. Okay, now the stress is compressive stress. Compressive stress, keep on writing. Compressive stress caused by dead load. So compressive stress due to the dead load is nothing but the its own weight, the weight of the pressure vessel. First of all, if there, so this is its own weight, due to its own weight, and it is always compressive. It's tied to decrease its height. Now, other compressive load may be due to the insulations. If it is jacketed or insulated, consider. So, there is a weight of the insulating material. So, that weight also caused the compressive stress, and the liquid it contains inside the vessel, that has also weight, and it also make a compressive stress. So now we will see the different expression caused by the its own weight, its insulating material weight, and its liquid weight inside it. So three expression. Now stresses induced by shell, stress induced by shell and insulation. Okay. So it will be, what is the weight of the cell? The weight of the cell is nothing but its own volume multiplied by density, cell material density. So its volume will be pi by 4 outside diameter square minus inside diameter square into x. This is x is nothing but the height of the vessel multiplied by its density, density of the solid. Okay, so weight of cell d naught di, not need to repeat it, that is the outside and inside dia of cell. X is the distance, okay, measure from the top, so from here to here, okay, so that is the distance, measure from the top of the vessel, and rho is equal to density of the cell material, density of cell material. So this is the weight. Now what should be the stress? So finding stress is very simple, divided by the cross sectional area, and stress due to weight of insulating, weight of insulation, weight of insulation. So pi d diameter insulation into rho of insulating material into the height of the insulating material and thickness of the insulating material. So what is W ins, weight of insulation, weight of insulation, D ins means mean diameter of insulation, . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . X is known, T is thickness of insulation, and rho is also understandable density of insulation. Now, so these are the weight due to the material's own weight, the materials and the insulating material weight. This is the second problem. Okay, so what is the compressive stress then? So compressive stress due to the weight of the cell, okay, is total weight, what I have written, pi by 4 d naught square by di square. This is x, not cross, rho is divided by the cross sectional area. So it is nothing but simply x into rho is. And similarly, the stress due to dead weight of the insulation is Fd weight due to insulation INS is equal to its total weight, you know it, okay, d rho t taking care all insulation into x divided by d mean diameter, dm is the mean diameter of the cell into ts. Okay, so you know what is the meaning of the mean diameter dm, mean diameter equal to d naught plus di by 2, which is already discussed. Okay, and ts is the, what is ts? Thickness of the cell. Thickness of the cell without corrosion allowances. So, what is FD? So, FD equal to rho insulation, T insulation thickness into X by Ts. So, this is the expression, or this is the stress induced by the insulating material. And what is another dead weight is due to its liquid content. So, next is the stress induced due to liquid due to liquid retained in column or vessel, whatever. So now you tell me that is liquid, LIQ. So liquid weight, how do you calculate the weight of the liquid? Weight of the liquid कैसे पता चलेगा? बोलो, is total volume into density. Total volume कैसे मिलेगा? The height of the liquid level multiplied by the cross-sectional area of the inner shell. So, वहाँ से तुम्हें you know what is the weight of the liquid and divided by the cross-sectional area. So, it is the liquid divided by the dm into cell thickness. So this is the expression. And so three different type of compressive stresses we have discussed due to its own weight, due to its insulating material, due to its liquid content. So overall expressions, okay, if there is a attachment, okay, if there is some attachment, okay, so stresses induced or stress induced by any attachment, जैसे ट्रे हो सकता है, ओके, कंडेंसर हो सकता है, any platform, ladder, pump that is attached with the cell. So any attachment, it may be condenser, platform for standing, cleaning purposes, ladder, etc. और भी कुछ हो सकता है. So for that case also, the stress is attachment, ATTACH, equal to the total weight of the attachment. The total weight of the attachment divided by PDMTS, is cross-sectional area. So now we know the individual expression of the stresses, compressive stresses. So what is the overall stress? So overall or total, whatever. So the stress is nothing but the due to the dead weight of cell plus dead weight of insulating material plus dead weight of liquid plus dead weight of attachment. So this is the expression for the overall compressive stress. ठीक है? Now do do this problem, very simple problem. Suppose DI is 1200 millimeter, PI is 0.4 Newton per millimeter square. Okay, allowable stress is 115 Newton per millimeter square. J value is 0.90. And thickness is suppose 2 mm. Okay, so these are the data. So you find if there is any how much change is there if we calculate the thickness based on the DI equation, okay, or if we calculate the thickness based on the D naught expression. So these are the expression PI DI, okay, 2PF two FJ minus PI, and another expression is PI D naught 2FJ plus PI. So you check how much deviations occurs if you calculate based on DI and if you calculate based on D naught. You calculate and tell me. D value is given, so D naught value will be, what will be the value of D naught? Bolo? What will be the value?
3863.
Huh? Hello? Yes. So DI plus 2T. So you now calculate and tell me for the value of T, how much differences are there. So within that time, let me roll call. One,
Present, sir.
two, four,
Sir, two roll number.
mhm, four, five,
Roll number 5 present, sir.
six.
Hello, yes sir, 4.
कहाँ थे? 6, 8,
Hello.